Hey, good morning. Welcome to the MassTransit live coding video prods. Well, I don't even know what they are really, but it's a lot of fun to do. So hopefully it provides some good information. So just a quick update, MassTransit 625 was released this past week. So a lot of the updates that we've done as part of previous episodes to support the different features are now available in the general release. So that's pretty cool. I'm also trying out my phone as a camera and doing it like over Wi-Fi, so hopefully it works. At least you can look at my nose now instead of looking at the side of my head all day, so that's always fun too. So enough of that. Today I'm going to talk about the In-Memory Outbox. The In-Memory Outbox is a capability that MassTransit has to ensure that transactions that used to be very dependent upon a database can now be done within the application context of using message consumers. And I put together a little bit of a sample, which is good that I didn't do it live because I don't use Entity Framework a lot and I had to learn a few things. So I'll kind of go through that as well. And I definitely took away some documentation updates that I'm going to put in there. So without much else, I'm going to kind of dig in here. First, kind of to set the context, within the MassTransit homepage, there's an update section, and I did a blog post about this, I guess, on February 7th, talking about what the In-Memory Outbox is, what it does, how it works, what value it brings, and the problems that it's trying to solve. So the In-Memory Outbox is designed to handle the case where you do something in the database and you need to send messages out and you want that to be treated as like sort of an atomic operation. And I say it's sort of atomic because there is no, messaging systems have, the more guarantees you create within a messaging system, the more expensive it becomes and the slower it becomes. So, the in-memory outbox, the issue that we would see is someone would go and do a database operation and then they would publish the message and something else would react to that message. What's been found is that, okay, well, the database transaction fails, but the message might have already been sent. So the system downstream continues processing, thinking the transaction was successful when in fact it wasn't. Or the database transaction completes, but the message isn't sent, and therefore the system sort of stalls because the database thinks the event was produced to trigger the downstream system, but it actually wasn't, so it didn't go anywhere. And that's another concern that people have. So what really, kind of solves this is what this outbox pattern does. Now, there are a couple of ways to build an outbox, and there's definitely been some prior art in this space. Most of those are very database centric in terms of committing records to the database as part of the transaction, and then having some process go and sweep those records and do the actual broker communication. And that's, it's a perfectly acceptable pattern. There is a cost overhead of actually doing that database processing, one that I didn't want to take on. And there's sort of a mental shift in terms of how the in-memory outbox is created. When you're building resilient and reliable systems, it's all about nines. It's nines or availability. We need to have availability. And one of I guess the mental things that a friend of mine called me out on was, you don't think that the database is important. And that's a big mental shift, I think, for a lot of people, because most people's coming in situation or scenario is that they think the database is the most important thing on the planet. And I don't. I don't think that the database availability is the key thing. I think that being able to support a partially available system is key to any distributed architecture. You have to be able to accept orders. That's like you have to be able to accept orders. If you're Amazon and you don't accept an order, that's like 1% of your business that goes out the door. So being available to accept orders is of the utmost importance. And then being able to process those, that's part of the fulfillment side that doesn't have to always be available. You can take a 5-minute break packing boxes, but you can't turn someone away at the front door when they're there to place an order. So the going in position that I have always had in this is that the broker is the most important person in the room. When you're building for availability, you've only got so many nines you can spend. And I would rather spend those nines ensuring that RabbitMQ is up, available, and always able to accept messages and confirm those messages than to worry about keeping a database which is designed to do atomic transactions up and running for an HTTP endpoint that's doing 30,000 requests a second to be able to service. So by setting that context and having that going in position, I think it sets the stage for why this is the approach that I took for building the Outbox. So hopefully that provides a little context. The blog post is out there. If you haven't read it yet, read it later, because reading it while I'm talking is going to bring no value, and I'll cover a lot of these scenarios as part of this. But I built a new sample, so that was part of the work this morning, is I built a sample around what I consider to be a pretty common pattern. Netcore App 3.1, which is the new long-term support version, so almost everything in MassTransit will be targeting that soon. It has an API endpoint with an API controller. It has a back-end service running in the new extensions hosting, and it's using Entity Framework Core. So I feel like a lot of the times I've just said, I'll just use Redis or I'll use Mongo. I wanted to use EF Core, one, because I haven't, and two, because I think a lot of people use it, and there are a lot of tricks to get it figured out that aren't obvious in the documentation. So I'm going to put that together in the docs at some point, but for now, we'll see how that goes. At this point, I'll bring up the code, but to do that, I will say, welcome to Trashlantis. So I'm a huge Borderlands fan, and Borderlands 3 has been a part of my life since September when it came out, and actually beforehand. And the reason I picked this little image is because it's cool, and I just replayed the DLC last week. But the In-Memory Outbox article talks about taking out the trash. And the story of your mom telling you to take out the trash when you're on the sofa and you don't do it because you're playing games, and then she tells you again, take out the trash. And it's this common concept of eventually you're going to get the message and do the job. So I wanted to kind of follow that theme and everything. So I named the sample Trashlantis. Hopefully that's fun. I am using the new 2020.1 writer, so everything seems to build on it. It has a few niceties, but I'm still seeing like just weird first release glitches, but hopefully they'll hotfix those pretty soon. But nothing breaking. It's been a pretty solid experience. It was an easy upgrade. So the solution structure that I have here is I have a Trashlantis API, which is just an API host. I have the components, in which case I have a state machine, which is where we're going to be doing our Outbox testing. I have a simple message contract called take out the trash, which just has a bin number. And that's the only thing I'm correlating on. So I wanted to also kind of show that you don't always have to have a GUID, but you need to have some sort of business identifier that tells you which trash bin to take out. And I use bin because trash can. It's not very continental. So I'll first go into just kind of the API endpoint. The API endpoint is simple. We're all familiar with the Swagger UI I have. I'm just going to do a post to this that says what the bin number is. And the controller that I have is a simple API controller that I don't know why I called it get, because I gave it the HTTP post verb, but whatever. All it does is it logs a message, says time to take out the trash. On the publish endpoint, it calls publish and then returns accepted. That's being available. The broker is the only thing I'm communicating with as part of my API endpoint. I'm putting a message out there that says it's time to take out the trash, and I'm just returning to the caller immediately with an accepted. They know the bin number. They don't need to know anything else. They're just like, hey, bin 42 is ready to go, because 42 is the answer to everything. The setup on that is super simple. I just have an add bus where I'm creating it using RabbitMQ. I add the health check so I can check the health of my service. I add the MassTransit hosted service, and I'm good to go. I have the simple Swagger wiring in here, map the health checks. Otherwise, pretty much the same as the Twitch sample. Everything's basically the same there. So I'm going to see what I have running. I did set up a Docker container for this, so I'm running SQL Server in a Docker container. I have RabbitMQ also running in a Docker container, and I'm going to be killing these as part of the example of how this works today. I have the website running right here. No, this is actually the service. I need to kill this because I don't want it running right now. this is the website. Okay, I have the website up and running. I have signed into my SQL Server through the bash script, so I can actually try to run some SQL commands to it if I need to, mostly because the first time I've ever set up SQL Server, and I had to figure out how EF migrations worked, which was pretty awesome. So the first thing about this is the API endpoint is talking to RabbitMQ, and that's it. If I go out to this website and I say I want to take out bin number 47, and I say execute, I get the accepted. It's all great and well. The message is out there. If I go and look, I can see that the trash removal state, which is where my state machine is, has that message in the queue. I can peek at that message. I can see that I have a request for bin number 47. That is a durable message sitting in RabbitMQ. It isn't going anywhere. It will be there. So from a transactional perspective, the acknowledgement of accepted to the HTTP client, I have the message. It's been committed to the broker. I won't lose that message. So that's step one. I didn't have to worry about a database availability or anything like that. It was very quick. I wrote it to the broker. The broker acknowledged that it had been written. Everything is done. So that's the first step. The state machine that I've created to handle this is the trash removal state machine. I'm going to go through this a little bit because it's going to cover some of the EF stuff, but the trash removal requested, it is correlated by bin number. So bin number is what I'm using for the correlation of this request. For the select ID, which is the ID that's assigned to the state machine instance, I'm just using newid.nextquid. I just want whichever one it throws out. I don't really care. And then the initial message, when trash removal requested, instance.bin number equals bin number. I copy the bin number over, and then I take the request timestamp out of the consume context. I just use the sent time of the message if it's there. If not, I just say UTC now. So I have a timestamp of when that request was received. At that point, I transition to the requested state, and I'm done. What I would like for this to do at this point is I would like to have some sort of service that's going to go out and actually take out the trash. So I'm going to create a consumer in here. I'm going to call this the trash consumer, or we'll call this let's just call it trash consumer. Sure, why not? And we are going to create a new a new contract for this. So if we go over to contracts, we're going to say empty trash bin, and I will pass the bin number, just as we did there. I will say that my trash consumer consumes the empty trash bin message. I will get a nice little logger. Save that out. I will do logger.log information, emptying trash bin, pass the bin number, context.message.bin number. I don't know, we'll do a task.delay, I guess. Doesn't really matter. I'm really just creating this so that we get the bindings in the broker. I don't really want it to do anything at this point. Yeah, so I have my trash consumer. I'm going to add that to my service, which is my Trashlantis service. At this point, the only thing I've configured is the state machine, but I'm going to go ahead and add that consumer while I'm sitting here. Add consumer. Okay. So I have a consumer, I have the state machine that we created that's sitting in there, and all it's going to do at the first part is, so now what I want to do is I also want to publish, what was it called? Empty trash bin, and I'm going to pass data bin number. That's it, because I'm going to empty that bin. So I want to verify that that works, and we're going to do one successful thing with everything up and running just to make sure that we get those log messages. I should probably write a couple logs in here, but I really don't feel like it. Let's just see if this works for first. So the way the program CS works is I add the consumer, I'm adding the state machine. You can see the entity framework repository. I'm using pessimistic concurrency because I just want to lock. Whatever. I have the capability, I'm going to use it. I'm getting the connection string from the app settings. I'm specifying the migrations assembly and the history table, and that's fun stuff there. Really good fun time there. The thing that I found that's weird is I actually had to create this design time factory so that EF could generate the migrations. Once I figured that out and how to pull the configuration in and use the DB options builder to add SQL Server and do this, I don't know if this is new to 3 compared to 2, but anyway, it's there, it works, and now it's like significantly better because now it actually registers the migrations and creates the database. I didn't know how to do that before, so I learned something new today. That's cool. So let's run this service just to verify that it's all good. So we're going to run Trashlantis. There is the message out there. It should do its things before it starts. We should see it create the instance for 47. We got the receive for the empty trash bin. We got the log message that says it's emptying trash bin 47. We see that the state did its thing. It created a Saga instance and added it. Hey, what's up, Albert? Albert just joined the chat. Yeah, so if we go out and look at the broker, and so that service was offline, but because that message was durable in the broker from the API endpoint, that was my partial availability. My backend was completely down, but I accepted that message on the API endpoint. I'm so used to looking to the right that I was thinking I was looking to the right, but now I can look forward. It's awesome. So the message is no longer in the queue because I've read it. You can see that there was the trash consumer, that's the trash default endpoint name for that consumer. It received that message. It processed that message. As we can see from the emptying of the trash bin, that it finished receiving that message. So all good there. You can see we published the empty trash bin. If we look out and look at trash, we can see that it's bound to the Trashlantis contracts empty trash bin event that we're publishing out of the Saga. Now let's start breaking stuff. We've done enough setup. Let's start breaking some things. We know that we have a service that works, so let's start breaking stuff. So we already kind of broke something by not having the service up and running. The fact that we wrote that message to a durable queue, we know that the message was there, and so that's the first one. We didn't even have to worry about the database being up. Once we brought our service up, it processed that message, did the transaction with the database, all was good. Now let's try to break the database, and I'm going to hopefully do this in a way that doesn't cause too much pain. So the outbox is there, yeah, and you can see based on this log. The question is, so this works in offline mode. I'm not sure I understand what you mean by offline mode. Yeah, I don't know what you necessarily mean by offline mode, but if the backing services are unavailable, the API endpoint can still talk to the broker and it can commit the messages so that the transactions aren't lost from the API perspective. If RMQ is down, okay, so at the beginning of the talk that you missed, I mentioned that you only have a certain amount of nines to spend, and the going in position that I have on this is that your broker has to be more available than your database. So definitely catch the playback at the beginning. I kind of covered that. But my position is that the broker has to be more available than the database because the database is something that we're probably going to change more than our broker. So I'm going to take and create a situation where let me start with RabbitMQ. Let's start first with the messages not being published. Now let's stick to the script. Let's take the database down. Hopefully I can do this. We're going to run the service in the debugger this time because I'm going to need to set some breakpoints and actually kill some stuff in the background. I don't have a really good chaos monkey sitting here, so I'm just going to have to kind of go with that. I'm going to set a breakpoint right here. The way MassTransit works when it executes a Saga is it will create the instance, it will open the database transaction, it will create the instance, you basically do a select to see if the instance exists, which will create a lock on that GUID. But there isn't a GUID, it's going to create a lock on the select for the bin number because that's the query by. Then it's going to do the Saga operations. Any of those messages are going to be queued up in the inbox because I've created in the definition for the Saga, and this is probably something I should go over too, is I've created a Saga definition for the trash removal state. First, I tell the endpoint I only want one message at a time, and that's just because otherwise I'll go insane trying to debug through this if we get multiple messages at the same time. I just want to make it simple so that we can show one at a time. It doesn't matter. You don't have to have this limit for the outbox. You can put it as many as you want. I've also set up use message retry, where I'm first going to retry after half a second, then I'm going to retry after a second, then 5 seconds, and then 10 seconds. Yeah. So I do think I'm going to make this last retry 30 seconds just because I want to be able to go and restart the database for the retry purposes. And here I'm using the In-Memory Outbox. So this is what's going to take any messages that are sent or published by the Saga and defer those until after the Saga transaction completes. Now I'm going to run this. See if it actually runs. I think, does F5 bring up the debugger? Yes, it does. All right, so it's going to bring up the debugger. Got my debug output. My service is up and running. I will now go over to the website, and in Swagger, I will create bin number 51. We'll hit execute. It should jump over to my debugger. Okay, so I've got a breakpoint. I'm in my state machine. The trash removal has been requested. The bin number is 51, and my database has already executed that initial statement. I don't know if I can see that over here in the Docker Compose output. I don't think SQL really writes any logs as it's processing. But I'm going to create another terminal window here, because now I'm within the database transaction. I'm going to Docker Compose down SQL Server. Okay, did I not get the name right? Is it down or is it stop? Stop SQL Server. Okay, stopping SQL Server. So now I'm stopping my SQL Server. It's going to stop when it gets there. What do you bet SQL's like? Okay, there it goes, it's done. So now I'm going to come out here. I'm going to run this. I'll have my publish. My publish will get called. Come on. Come on. Let me select you. Okay. So I'm going to do the publish async. So I'm going to step through this. I'm going to call publish. And I'm going to... I think it's stepping. Don't know what it's doing. Oh, this SQL transaction is completed and is no longer usable. It already failed because I hit go. Okay, yeah, because it went. You can see that it's retrying. It's trying to reconnect. SQL zombie. If I go ahead and restart that, what do I do? Say start SQL Server. I don't want to. Okay, so now it's going up. Sorry, that was probably really bad that I just saw NAT and smacked it. I might be used to that. It's bringing the database back up, and I hit my breakpoint again. So I have retried. I took the database down. My message is still in the queue. It's going to retry. My retry hit. I get up here. I've got the bin number. I'm already processing again. I'm in the initially because my Saga instance didn't exist because the database was taken down. I didn't have to restart my service. I didn't have to do anything. It just worked because the message is in the queue. The message retry was there. All is good there. So now if I go through this, I go through this, I look down here at the bottom, I can see that my insert into the trash removal state was successful. I declared the exchange, I sent the empty trash bin, and the trash bin consumer emptied the trash. If I go up here and look, and I scroll all the way up here to where like the first error was, I can see that when I tried to insert this and it said an error occurred while inserting the database transaction, the publish happened. Make no mistake, the publish happened. It was called, it was sitting in the outbox, but because the database transaction failed, the message was not sent. It did not get sent out the broker because it throws it away. That's why it's an outbox. The database transaction eventually reconnected, it sent the message, and I was able to process that. So I didn't send a message in the presence of a database failure. That's the first case. The second case that I want to account for is the case where the broker goes down and doesn't send the messages. So this is going to be a little trickier one to catch, and I'm trying to think how I'm going to grab it. It's a little harder to do in this scenario because I essentially have to have like a, how am I going to hang this one? Because basically the Saga has to finish, and I need to do something that lets me catch the behavior before the outbox does its publish. Okay, so I'm going to do something really kind of crazy here to catch this because I can't think of how else to do it. We'll put another movie reference in here. And this one is going to be a filter of consume context of, what's my message called? Take out the trash. This is going into some crazy time here, but what we are going to do is we are going to await next.send context, and then we are going to we're just going to do something simple like console write line hello, just something stupid, just something I can set a breakpoint on. And then we're going to say endpoint configurator.use filter, new catch me if you can. Say, did it take out the trash? No. It needs to be before the Saga, but it needs to be consume context. That's not what I want. Use filter. Doing consume context. Let's just even simple it. Let's see what happens if I make it consume context. Okay, perfect. I don't need the message type. I'll just take the message type out of it. Do this. I'll set the breakpoint there. And this will give me a filter that I can set a breakpoint on so that I can catch it before it goes back to the in-memory outbox, which is going to then publish those messages. So this will give me a chance to take down the RabbitMQ connection and break it. Okay, so I'm going to run this through the debugger again. At this point, I'm up and running. I'm going to go create another trash bin. This one's going to be 52. Going to run. You can see my bin number is 52. I'm going to go out and I'm creating this transaction. I have the publish call here. I'm going to hit go. I'm going to hit go. So I'm at this breakpoint here. Now, if I go out to RabbitMQ and I look at the queues, there isn't anything in the trash queue yet. Nothing has been picked up there. It isn't doing any work. I'm going to come over here, but the database transaction is done. And how can I show that? Let's see here. If I, oop, not that one. Oh no, it exited out. Shoot. See if I can figure this out. I have to type this in here because this is just tricky. Quartz information Docker for SS. Okay, so if I do use Trashlantis, there's probably better tools for this, but I just don't have them. Select star from trash removal state. So the trash removal bin number 52 is already in the database. The transaction is committed. It's visible to other consumers, or other database connections. So it's done. It's ready. It's in the database. But my messages haven't been posted yet. They're sitting here waiting for me to clear this up so the in-memory outbox can post it. I'm going to kill RabbitMQ now. So I'm going to come over here. I'm going to say docker compose stop RabbitMQ. It's going to stop RabbitMQ. I'm going to hit go. It's going to fail a completely miserable death of RabbitMQ not being there. So it has failed at this point. I'm going to have a ton of errors here. It's going to try to reconnect, and it will eventually reconnect, and it will do its thing, and it will pick it up again. But I'm going to kill this because I want to show what's in the broker once I bring it back up. So I'm going to start RabbitMQ. That comes up. It takes it a second. Okay, RabbitMQ is coming back up. I look at my queues here. No, hold on. Let's try that again. Brew services stop RabbitMQ. Yeah, that's funny. Now when I was about to refresh. Hey, now there's the correct instance of RabbitMQ, the one from Docker. So awesome. If I look, my trash removal state, the message is still there. So message 52 is there for bin number 52. So the message was never lost, but the database transaction is committed. So the case that I need to handle here, I'm going to eventually stop looking right. It's, you know, there's only hours and hours of me looking to the right. So now I'm just going to eventually figure this out. The message is now, so I still have the message in the queue. I still have the database transaction, which has already been committed with the state. And that's the key thing, is the state that that is in is the state is 3, which if I go back here to the state machine definition, state 3 is requested. So there's state 1 and 2 are initial and final. Those are built-in states. I'm using an int for the state, so I have to map out explicitly the states for the instance state property. So just showing also how you can use ints instead of strings, which, you know, makes your DBAs happy. So the state machine isn't accounting for this yet. Right now, the state machine has 2 different capabilities. It says, well, it has one really. It says initially when the trash removal is requested, then save the bin number, save the request timestamp, and publish async. Now I know that I can get this message when I'm already in the requested state if there's an issue talking to the broker because of the outbox. So because I'm already in the requested state, I'm going to say during requested when trash removal requested. So when they ask me to do the same thing that I've already done, I'm not going to copy any of the data. The only thing I'm going to do differently is I'm going to publish that message because I know it could have failed. Missing a semicolon? Okay, great. So I have the initial publish for the bin number. I'm going to add another one which says, okay, I'm just going to republish that message because I'm already in the state, because I know that that happened. And if the message is going to be replayed because I had a broker connection issue, I'm going to just say, okay, well, I need to send out that same message because if I didn't acknowledge the message, removing it from the queue, more than likely I didn't publish the message that went out. So with that one little change in there, I'm going to set that. I'm going to try to set a breakpoint here. I think I can. Yeah. I'm going to go ahead and run this because this is going to start picking messages up from the broker right away. And you can see my breakpoint was hit. The database transaction had already completed, so my state machine was already in the requested state, and I once again received that trash removal requested message. So the only behavior I'm going to do again is one that I know was not transactional, was the publish to the empty trash bin. So I'm going to republish that message, and then I'm going to see that it hits my filter. I haven't published it to the broker yet, but now I'm going to go ahead and let that happen. And if I go out to the console, I can see that my Saga finished. There wasn't anything to update. I mean, it basically just did the initial select because I didn't do any changes to the Saga. It doesn't have to do anything as part of the transaction to commit it. There's no update. And then the consumer was able to get that empty trash bin command. Yeah, so those are the scenarios. Let me take a look here and make sure I didn't miss anything. Let's see here. I covered the databases down. I covered the database transaction. I covered the connection dropped. Went over the initially versus during in the state machine. Yeah, that's how the in-memory outbox was designed to work. It covers the scenarios. The going in position is that you're using the broker as your durable, your most nines solution. The nice thing about that is you can take the services down, you can update them, you can take the database down and apply enterprise cumulative update 27 or whatever it happens to be for that week. All of that stuff is able to be done, but you're still available to take orders, and that partial availability and having the most important pieces of your system available to process for customers is the key. I'm not going to take a whole lot of time to go over like building a query against this because we've done that in the other examples like we did with the sample Twitch on how to query this order state. But all of that could be added to this as well. So the question that just came in is, so what if I have to update RabbitMQ? Yeah, I mean, you're always going to have to do that at some point. You're going to have to apply patches. You can do clustering with RabbitMQ. You can roll nodes over. So as long as you're within the same major minor, I think you can bring up nodes on the same major minor in the same cluster and roll them over. MassTransit does support connecting to clusters. You can also just use an HA proxy type setup to talk to RabbitMQ and basically fail over to your backup node, upgrade the primary node, fail back over to the primary node, and then upgrade your backup node. So there are, and databases have these policies too. You can do database failovers. They usually aren't as immediate, but they're quick. I mean, they're there. But there's a lot more machinery involved in that. I mean, it's the thing. They're your nines. You're spending your nines on your broker. You're going to have a good policy to upgrade and do rolling updates, or basically active passive updates of your broker. So it does support the same capabilities RabbitMQ does. If you're using a PaaS broker like Azure Service Bus, they update that. So that isn't going to be something you're going to worry about. And if MassTransit is going to be smart enough that if it loses the connection, it's going to reconnect and pick up where it left off. Those messages are going to be durable. And if the acknowledgement is only made to the broker when all of the activities have completed, including sending or publishing messages. So yeah, it's resilient, which I think is an important aspect of any system that you need to be available, because it needs to be resilient in the case of failures, losing database connections, losing broker connections. All of these things will happen. If your service exits because it got dropped from a connection to, whether it's RabbitMQ, Kafka, whatever, that isn't resilient. That creates a problem, because then either you have to restart the service or and then there's ways to deal with that. But I think the services shouldn't have to exit and lose all their state and have to come from a known zero just because it lost a connection to a backing service. So that's kind of where I'm at with that. Hopefully this provides some information. Definitely check out the blog post if just to kind of get some of the background on that. It does differ from the case of where you're writing directly to a database and then sweeping that database to produce messages. It's a different approach. It's a different coming in position of what's important. I will push this sample up. I don't know if I'll put this on the MassTransit repo or on my repo. But I'll put a link in the video once I have the sample up on GitHub. But yeah, so that's the in-memory outbox. That's how it works. I think I covered enough of the use cases. So enjoy the rest of your Saturday, and we'll catch you on the next one. Take care.